Hi everyone. Today we're going to put our notes together for our Unit 2 section on slope. So what you see on our handout is we start off with slope. Slope is rise over run, and the definition of slope is our vertical length over our horizontal length of a slope triangle. So if we looked up here at our slope triangle, we would actually see the vertical length of the triangle and our horizontal length of our triangle. So our vertical length is known as the rise because we're going up and down. And our horizontal length going left to right is our run. So in order to find the slope, we would need to find 2 points on the slope line to make a slope triangle. So if I look over here, when we're looking for those 2 points, remember we're looking for points that land right on the crosshairs of the grid. So here'd be 1 point. We can see the other point right up there, and then our third point up here. So all you need is 2 points to make your triangle. So once you have your 2 points, you would move over the horizontal length and you'd go up to the vertical length, or you could even do the opposite. You can go rise all the way up to that point and go over. Either way of making your triangle is fine. Once you have your triangle created, you're going to count the rise. So what you're doing is you're trying to find the length of the vertical line. So here's my vertical lines. You're counting your squares. 1, 2, 3, 4, 5, and 6. So this length would be a 6. And then you would count your run. Your run is the length of the horizontal line. And if you count, again, count the squares. 1, 2, 3, 4, 5, 6, 7, 8. So we have our rise, we have our run, and this will make our slope ratio, the ratio that we need to identify slope. So we know that slope is rise over run. So if our rise is 6 and our run is 8, that would be our ratio. And then the last part is to simplify your slope if possible. So I look at 6 and 8 and realize that these are both even numbers. So I should be able to divide both of these by 2. So 6 divided by 2 would give me a 3, and 8 divided by 2 would give me a 4. So my slope would be 3 over 4, and you can actually see here's a larger slope triangle, but the smaller slope triangle is 3 out of 4. So you can actually see how these, no matter what size slope triangle you make, you're always going to get it, they're always going to be equal to each other. All right, so underneath, so important information on slope. Slope is the diagonal line of a slope triangle. So it's always this diagonal line that makes up that triangle when we talk about slope. Slope, we also refer to slope as being the steepness. So that number represents how steep the line really is. So the slope of 3 over 4, tells you you're going up over 3, and it kind of tells you what kind of line you have. One thing to keep in mind, the smaller the fraction, the closer your line gets to being flat, gets to being horizontal, and the steeper your line, the closer it is, the higher that number is until it gets completely vertical. So you can kind of take a look at what kind of slope you have based on what kind of fraction you have, and you can kind of see the difference of those slants. All slope triangles on a slope line would have as you notice, they have the same slope. And any lines that have the same slope, so if I have 2 different lines on here and they both have the same slope, we learned in our activity that the lines with the same slope would be considered parallel to each other. And you could actually see it up here. If I picked another point to start at, and if I went up 3 up 3, 1, 2, 3, and over 4, 1, 2, 3, 4. And if I was to make this line, you could actually see Oopsie, I'm a little bit off here. But you could actually see that this line would be parallel to that line. So that's what we're talking about. Same slope lines would also be parallel to each other. All right, the bottom part, kind of move our screen a little bit, is all about the equations of the line. So we know that an equational line is y over x. Y over x represents a point, any point that's on this line. So y over x represents a point that would be on that line, and we always equal to any point on a line is equal to the slope, which we learned above. Any of these points on the line up here would be equal to this exact same slope. So if we know that information, the first thing we do in our graph is look for what the slope is. That would be our rise over run. So we would have 1, 2, and a 3 over here. And we'd have 1, 2, 3, 4 over here. So my slope would be rise 3, run of 4. So there would be my slope. So my equation would turn into y over x, which represents any point, equals our slope 3 over 4. So there's our equation. So if you're asked to write an equation, this is what it would look like. So then what did you have to do with that equation? Well, now you can be able to identify if any point, if I give you a point, whether you can see it on the graph or not, you should be able to tell me if that point would be on the line. So if we start here, here is our slope. Now we're going to replace the y and the x with the point that we're given, or any point that we want to check. This point is 2015. So remember, 20 is my x value and 15 is my y value. So my y goes on top. That'd be a 15. My x on the bottom, there is your 20. So now we have a couple things to do to prove to see if this is similar. They should be equal fractions. One way to check is to see if you can find a scale factor. So 15 divided by 3 would be 5, and 20 divided by 4 would also be 5. So they both have the scale factor of 5 or 1/5, depending on what direction you go into. So those are the same. Another method you could do is you could look at the decimal. If I did 15 divided by 20, that would equal 0.75. And if I did 3 divided by 4, that would also be 0.75. You will notice that both these numbers are the same. So therefore, if the decimals are the same, the scale factors are the same, this is a point that would be found on that line if we were to extend it. The answer is yes. 2015 is on the line because the ratios are equal. They have the same scale factor if you use this method, or they have the same decimals. So we just proved that the equations are equal to each other. All right, and the last one is this point on the line. So 90, 68. So we're going to put our 90 is the x value, 68 is our y value, and the exact same concept. How do I can go from 68 to 3? So you put in your calculator, and it should be 22.6. I think, is it 22.6 or is it 22.6 repeating? So let's find out. So if I do 68 divided by 3, yep, 22.6 repeating. So I put that little repeating dot. So that's one of the scale factors. And now let's do the bottom. 90 divided by 4. And this one is 22.5. Are those the same? Those are not the same numbers. So right now we know the answer to this will be no. But now let's prove it with the decimals. So over here, we'll do the decimal of 68 divided by 90. So if we take 68 divided by 90, we get 0.75 repeating. Is 0.75 repeating the same thing as 0.75? And the answer is no. So because these decimals are not the same, 0.75 repeating and 0.75, we have our answer is no. Why is it no? Because the ratios are not equal to each other. They don't have the same scale factor or the same decimals. So there's everything we've been covering so far in slope in a nutshell. So this should be a good review of what you are doing at the end of Unit 2 and to get us ready for what we are coming up in Unit 3, which is we're focusing a lot more on the slope in Unit 3. So there you go. See you guys later. Bye.